Hello students, I have come up with another IIT level problem expected to be asked at the advanced level. So the problem is like this. A disk of radius r and mass m rotates with angular velocity omega 0, is dropped to the ground. Find the time interval after which it starts rolling. Something like this. It's a spinning disk. You drop it to the ground. Spinning disk is dropped to the ground and it will rub with the ground like this. It will rub with the ground. This point has a backward velocity initially when it drops to the ground. Therefore, frictional force will be a forward. And when it rubs with the ground, this point of contact, which has a velocity in the back direction, the velocity of this point of contact will reduce, but it is going on rubbing and forward, and finally at this point the point of contact will have zero velocity. The moment this point of contact has zero velocity, the body starts rolling. There is a condition for rolling. The point of contact, the moment the point of contact has zero velocity with respect to the surface on which it moves, the body starts rolling. So rolling starts from here. We have to find how much time it takes from here to here. From here to here, the body is rubbing with the ground. तो मतलब ये है कि ये जो frictional force है, it has the maximum value, and frictional force has the value of mu n. Because when it is rubbing with the ground, so this F is equal to mu n, that is mu mg. As always, when the body rubs, the frictional force is maximum. Now, how to find the time from here to here? Time till it starts rolling. And you know what's the condition for rolling? The condition for rolling is the point of contact should have zero velocity, and also the center of mass velocity is equal to r omega. This is also the condition for rolling. Right? So, how to start with it? First of all, let me concentrate on this point of contact. This point of contact is this point, and the frictional force passes through this point. Therefore, frictional force will not create any torque about this point because it passes through this point. And mg also, that also passes, that's vertically downwards, like this, that's vertically downwards, that also passes through this point. Therefore, both the forces, they will not create torque about this point of contact. It is clear from here because mg and f pass through this point. So the torque about this point is zero. When torque about this point is zero, that means angular momentum about this point or this point remains constant. So therefore we can say the angular momentum of this spinning body initially remains the same. But the angular momentum about what? About this point? No. Not about this center of mass, about this point of contact point, because the torque about the point of contact is zero. So what is the step one? It involves many concepts. First of all, it involves the angular momentum concept, then it involves the torque concept, then so many things here. A rolling condition V is equal to r omega. Again, the rolling is when the point of contact has zero velocity. So many things are involved in this problem, right? Okay, step one. What is the angular momentum of the body, of this body about this point? Initially, when there is no velocity in the forward direction. Because initially it is dropped at the point of center of mass has velocity zero. So it is angular momentum here initially is that is I omega 0, because the angular momentum about the center is I omega 0. And angular, because it has no translational angular momentum, it has only the spin angular momentum, that is this. Should be equal to what? What is angular momentum of this body about this point here? Here about this point it has two angular momenta. One is spin angular momentum I omega, other is translational angular momentum, because the center of mass is moving in the forward direction. So what is the angular momentum of the body about this point now? That is I omega. If omega is the final angular velocity, then it starts rolling, plus m V, that's momentum forward, into R. This is the equation. Why should the angular momentum be constant from here to here? Because the torque about this point is 0. Why the torque about this point is 0? Because the force passes through this point. As simple as that. So let me solve this. It is a moment of inertia is 1 by 2 mr square omega 0. It is moment of inertia of the body about the center of mass, that is 1 by 2 m r square omega plus m. What is this v? That is r omega into r. mr square and mr square finishes off. So it is 1 by 2 omega 0 is equal to 1 by 2 omega plus omega, that is 3 by 2 omega. 2 gets cancelled. And what is omega? Angular velocity when it starts rolling, that is omega 0 by these 3. So we got the answer to what? The omega, the angular velocity when it starts rolling, is 1/3 of the omega 0. So that means angular velocity has decreased. So next step number 2, what should we do now? In order to find time, we had to do so many things. Can you tell me what is this velocity, final velocity from here to here? It starts with initial velocity 0, but it achieves the velocity v because there's a frictional force in the forward direction. This frictional force will accelerate the center of mass. It will accelerate the center of mass, and finally the center of mass will have greater velocity. So what is this velocity equal to? That is simply v is equal to u plus at, time taken from here to here. So it is v equal to u is 0 plus what is the acceleration? That is f by mass of this disk into t, and that is f by m into t. Right? Now third step, this is omega 0, this is omega. Why the omega has decreased from here to here? Because there is torque about this point, not about this, about this point. So that means there's a torque about this point due to this frictional force. This frictional force creates torque about the center of mass, and that torque is opposite to this omega. I mean, it will create an angular acceleration which is opposite to this omega, and that is why this omega 0 has decreased to omega. How much is the torque produced by this f? By this f about the center of mass. That torque is equal to Fr. What is angular acceleration? That is torque by moment of inertia. That is Fr divided by 1 by 2 mr square. 1r gets cancelled. That is 2 times f. This will go up by mr. That's the angular acceleration. Now, can you give me what is the relation between omega and omega 0? The relation is, that is kinematic equation, rotational kinematics, final angular velocity is equal to initial angular velocity plus angular acceleration into time. Is this similar to this equation? So what is omega? That is omega 0. Alpha is negative. It is a negative sign. Why? That I will tell you. 2 times f by mr into t. You see, torque is r cross f. R is this direction, r cross f, that is opposite to omega 0. So that means this torque will try to reduce the angular velocity. That is why angular acceleration is negative, right? Because it is opposite to omega. Now, fourth step is what? Let me go to the fourth step. Let me go to the fourth step. Fourth step is v, final velocities or omega. Now what is v? Okay, that's f by mt, f by m t. R is r, and what is omega? That's omega 0 minus 2f by m r and Okay, that is T. Now I should write it like this: Ft by m is equal to r omega 0 minus 2f by r will cancel by mt. Right? Simple steps, mathematical steps. Simple mathematical steps. Now let me get this onto the left side. That makes it 3f by mt r omega 0. Now what is t? Time that we have to find. How much time it takes from here to here till it starts rolling. Till it starts rolling. So t equal to r omega 0 m multiplied by 3f. This f. Now t equal to, but what is f from here to here? The body is rubbing. The disc is rubbing with the ground. When something rubs with the ground, that means the frictional force is maximum. That's mu mg, yeah, mu n. But normal direction is always equal to mg. So far the body is on the ground, flat ground. So it's r omega 0 m by 3 times mu m and g. M gets cancelled and is equal to r omega 0 divided by 3 mu and g. That is the answer for time. So this is advanced IIT level problem where so many concepts get involved. It involves angular momentum, it involves what we call as torque, it involves relation between torque and angular momentum, it involves condition for rolling, it involves frictional force. So it deserves to be called as advanced IIT level problem, most expected problem at the advanced level. And if you like this problem and if you like my lectures, you can subscribe to my channel and also recommend the channel to the other students so that most of the students get benefited by these daily lectures. Thank you.